Okay, the next vehicle we are working on tonight is a 2012 BMW X5M, I believe. And it was brought to me by a customer who just bought it, and apparently it's got a battery draw. It dies fairly quick from what he was describing. Um, they've I don't know if it was him who put a battery in it or the dealer that he bought it from put a battery in it, but apparently someone's put a battery in it and it still dies. Um, and so I've attempted to do the draw test on it before, but I've been kind of on and off, so I haven't been able to fully put 100% attention to it. You kind of have to really be on the car, basically like 100% when chasing a draw, especially on these higher end European vehicles or any that just have a bunch of modules and stuff that could be the cause of a draw. So you can't just oversee something and or not pay attention to something that might be simple or something that's obvious or not obvious. You just have to fully check every possible circuit, to find the draw. Uh, I've run in the past with these BMWs where it's not just one definite module. It could be multiple ones at one time, and that just crossed that threshold of just too much amperage draw. Possibly one might have been up to a certain amount or on just a certain amount of time with a certain amount of draw and shuts off just in time. You have to monitor the amperage and visually try to see it and see how much of a draw and try to isolate it and find it and see if it's just one or more than one and kind of go from there. So the way that I approach my battery draws, and it doesn't matter whether it's a high-end European or a generic, you know, dumbed-down vehicle. I always make sure batteries has a good charge, fully charged or new and replaced. I typically try to find out where all the fuse panels are beforehand, and have them exposed or accessible. Second, I try to open up as many doors that I need to and latch them, so that in the middle of testing I'm not opening a door and waking up a body module because of it seeing the latch or door handle move. So open up whatever doors you think you're going to need and latch them. Open up the hood and pull the hood switch or latch the hood latches, make it think that the hood's shut. The same with the tailgate and trunk. And just make everything as accessible to you that you think you'll need to access while the car is quote unquote asleep, if it has a draw and you need to start poking around the car. Worst thing you want to do is wake up car up and have to start all over again, which that's part of what's been going on with this vehicle. It I woke it up at one of the points and I had to shut it down or start over again. And at that point, the draw had been going on for so long and brought the battery down to a certain level. So then I had to get the charger back out, and start all over. But that's part of it was bouncing around from car to car to car. So tonight, here alone, cause just gonna concentrate on this and knock this out, try to figure it out, and try to bring you guys along. I usually don't do any recordings when doing battery draws, just because I just get started and get going, or they're just a pain in the butt. So I guess ride along and see how much fun we can have, and I'll get you some shots of what we're working with. So I've got the hood open, like you can clearly see. I've got this passenger door open because this has two main fuse panels. Got a front one and a rear one. The front one is here under the dash. I've already unbolted it, trying to make it as accessible as I can. And again, I've got my latch latched. And then the second main fuse panel is right here, which I've got that unbolted already. And then obviously we've got the battery here, and then the rear is still closed, latched, and then the driver's door I've got latched. You might have seen the door handle hanging, and that is because this vehicle has what they call comfort access. The way you can tell on these is these striped grooves on the handle. That's a sign that this vehicle has comfort access. Now what that means is that it's like the keyless remote type system, where the handles are actually antenna modules, and they'll by touch or by breaking capacitance field on the inside part, they'll lock or unlock the vehicle. And that was part of how I ended up waking it up the other day, and I actually kind of just brushed by it and it ended up unlocking or waking up. So I've got this one unbolted and hanging, but still plugged in, because the day the vehicle got dropped off, I noticed that the handle felt warm compared to the other handles. And part of that, these are sort of known for having door handles that kind of basically short out and stay to the point where they draw all the time, and then they heat up and they're warm to the touch. So I've got this unplugged, so I'm ready to disconnect it if I need to, in order to watch the amperage drop if I'm suspecting this. So if I need to do with any of the other ones, they're not that hard to do. So there's a little cap there, and then a little Allen screw, and then you take them out. The other thing that I need to actually plug back in, thing I noticed, the customer came in with this unit here, so I need to get that plugged back in. You want the vehicle in whatever state that the customer uses it in, to try to duplicate and replicate the draw. So I've got that plugged in, all the doors latched the way I want them, and I've got my meter here that I'll set up. The way I set it up is I use this is a 10 amp fused meter, so I'll use this kind of breaker deal with a 10 amp protector on there, and I'll go to the amp scale there for my hookups. And the way I do it, I always go to graphing meter. You can use the scope and stuff, but for amperage, and I don't use amp clamps. I don't like to use amp clamps when doing battery draws. And why? Normally when you change your ways of doing something, it's because you've experienced something and you've got burnt. And that happened to me. It was actually on the Ford. Nothing crazy, but I was used to do draws with amp clamps, and they're just, for me, they're just not accurate enough and reliable enough, and I ended up just getting burned. It was basically getting inaccurate information from the amp clamp, the way the circuit was set up and the power supply split, and it's just I don't want to get burnt. These take long enough to do, and for me, I feel more secure in knowing that every single bit of actual direct amperage is going through the meter. It's got no other way to go. It has to go through the meter because we hook it up in series, because we're measuring actual amperage directly through the meter, and you're going to pick up every single last bit. Amp clamps, you're only hoping that you're seeing everything and to the correct level and or amount of amperage that the clamp is supposedly capturing. Now these are, especially these higher end vehicles, the milliamp level is, pretty much what you're gonna go by. Here's a list. This is from BMW that I've got, that I tend to go by. You find your chassis, and then there's the allowable amperage draw with the time also that it takes for the vehicle to go to sleep. So as you can see, some of the older vehicles, 50 milliamps was fine, 40, 30, 50. Most of them here are 40. So you want to be able to try capture a good, accurate, detailed spec, so you can compare it and make a determination if there is an actual draw or not, because these vehicles will, a lot of modules stay running in the background, whether it's a TCU like a phone module, or one that wakes up like a power module, check voltage, and then goes back to sleep. It's normal. So you need to know an exact level of amperage being used, and you need to decide if that's normal or not. And this is the best way that I found and that I'm comfortable using. This chassis that we have, it's an E70, 40 milliamps, up to 40 milliamps is what you're looking for. And look at the amount of time. After 60 to 70 minutes, if it's got a TCU, that's a telematics control unit, and after 30 minutes if it doesn't have one. So I'm pretty sure this one is going to be on the longer end, but if we've got a draw, we'll know. And like I said, I know that it has one, so, but we'll still wait that amount of time, come back and check, and then from then on you need to decide, or the best way on these vehicles, because there's so much circuits, you need to try to split it between the rear and the front, And then once you decide that and find that, then you start attacking all the circuits per fuse panel and go from there. Then you find out what it is and stuff. But these are a little bit of a pain. You have to be a little bit knowledgeable with the circuits and how they work and everything. And like I said, know that there's rear and front distributions and how it gets isolated. You need to isolate it and go from there. So enough talking. Like I said, this is a battery that the customer, or one of them, had gotten. For starters, it's too small of a battery, but we'll address that once we find the draw. And I'm pretty sure they did not program it or do a battery registration when they put that in. So let me get my 10 mil, because I did have the terminals unplugged when I was charging it. So I'm only going to tighten up the positive side, and I always hook up on the negative side. Okay, so here's my negative cable, and here's my negative post. The negative lead goes on the most negative side of the circuit, which is going to be your negative battery post. And the other reason why I don't use meters anymore for a draw is because I want to have it in a graph form as well. Because if you just have a number displayed, you're not seeing the activity throughout an extended period. Like if you use your min and max, and your max was, I don't know, say 5 amps, you might think there's a 5 amp draw, but if it's just one single spike for, a millisecond or something, and it happens, say, every half hour, that's not going to draw your battery, and it could be a normal activity. Like I said, these vehicles will have things that randomly wake up, take measurements of stuff, and go back to sleep. They just want to wake up and look at stuff and make sure everything is still fine and normal, and then they go back to sleep. It's a normal operation. So if you see all flatline and one spike, and then 10 minutes or half hour you see another one, then it's just one single spike, and it's not a full on draw and then shut off. So that's the other reason why I don't like meters as well, or just a number, because you're not seeing the whole activity. So if you can, try to get used to doing it that way, when you can put up your number, but then graph it out as well. So you get a better visualization of what's going on. So I'll stop it and start again. I'm on the 10 amp scale. It's the highest I can go. And then there is that. Now, the other thing that I like to do once I'm hooked up is I like to go into the car and cycle the key on real quick and shut it off, get out, latch the doors, and hit the lock button so that it's in its lock state, and attempts to go to sleep in that way, almost like how you would leave it parked, overnight and locked. This vehicle, for some reason, well, when I had it locked, like I said, it kept waking up on me. So this time, I'm gonna start it and just leave it unlocked. I might try to cycle the key though, just to wake everything up and shut them down. So basically, you want to power up components, power them down, and that way you can start some of their functions or wake them up, and then after you wake them up, you want them to go try to start attempting their sleep mode. So maybe see if we can put it in. Okay, pull it out real quick on this one just because it draws a lot of amps. That's how I know it still hasn't blown the fuse. And for right now, it's above 10 amps. And it'll come back down. But normally at this point is where I would hit I would lock all doors and make it try to start to go to sleep that way. But let's see, and then what I like to do, so 808, I'll start with 808, say 9.7 amps. And that way we'll start our clock, and then about an hour and 10 minutes, we'll come back and see what our number looks like. And then, like I said, this is why why I do the graphing mode. So you want to be able to see what's going on. So yeah, so it's below 10, just below 10. So this is when I turn the key on, and it's staying up there awake right now. And eventually, hopefully, it'll drop to a certain point. But that's it. That's how I get them started. And I actually just heard a relay click there, and that's when the drop started. So, and like I said, there's that was the fuel pump. During this first hour, there's really you can't call a draw. Always make sure, and I always look this up. I don't care if it's a Chevy, a Ford, a Benz, a Beamer, whatever. Always look up and see what the sleep time is. Some Ford, and I was surprised to see this one. Once I started working on domestics, checking draws, some Fords are 45 minutes. I never would have thought that. But you've got to wait. You've got to make sure you look up the spec for the sleep time. Because I could come back here in 10 minutes and have it be in a 6 amp and be like, oh, it's got a draw, blah blah blah, and then not knowing I still had another hour to go before the car fully goes to sleep. So always make sure, look up that information. Don't make any calls of saying there's a draw. If you don't know the time period, you could be making the wrong call. So look up your information, hook up your equipment right, and make sure to timestamp, keep records, and then after that is when the fun begins of trying to chase and find what circuit's staying awake. So for now, I'm going to put you guys down and come back in an hour. Okay, so it is now 9:36. We've let it go 20, 30 minutes over. So should be well asleep with no draw. And we are at basically just about 4 amp draw. That's pretty decent. So that is gonna kill your battery pretty quick, which kind of matches what the customer was saying. So now, like I said, it's been over an hour of setting up your equipment, getting your information, knowing how long to let it sit, come back and check. And now comes the fun part of finding where this 4 amp draw is. Now keep in mind there needs to be at least 40 milliamp or less. So you got to take that away from there, and then that's basically the extra amperage that you're having that you need to find. So we need to find out and get it down somewhere within that window or less. And first things first, we need to decide if it's in the rear distribution box or in the front one. Normally, if you want to go crude, and in other vehicles I have, BMW ones, you have this main, let me get this. You'll have big fat cable that'll feed each distribution box. This one here feeds that. The front one has a similar one, but these got a funky connection that is not too conventional, and not surprised, but other ones will be bolted in with a like a 13 millimeter nut or whatnot. But and I'm gonna contradict myself here from what I stated earlier, but this is only for ease of use and not accuracy, because I cannot unplug that from the rear distribution box to see if that goes away, or vice versa with the front. Because if I unplug that goes away, then I know to look for something here in this panel. If it doesn't go away, then we know it's up front. But I am going to go ahead and take my amp clamp and go around the big fat cable power feed to each box, and I'm only using that for a guidance to see where the high amperage draw is at, if it's in the front or in the rear. I'm not using it for accuracy as far as exact draw. I'm just using it for a guidance. Once I do that, then I'll start poking the fuses with the meter and trying to go from there. So let me get the amp clamp, and then we'll get you a shot of that. Alright, so we're still at just under 4 amps. I've got the amp clamp and I'm running there. Let me first go to this rear junction on the fat feed cable, and we are jumping up close to that 400 millivolt, which when converted is pretty close to the number we're seeing, just under the 4 amps. So now I can pretty much have a good guess as to what the front distribution box is going to look like. But let me roll you guys over there and excuse me. Let me get you a shot of that as I try not to hit anything. Okay. Alright, so here is, go hook up to the front distribution box. Great. Yeah, let me go get my light. Actually, it's right here. So I'm on that big feed cable. And there's activity on it, but it is close to that zero line. So I'd say it's safe to bet that all of our amperage activity is being drawn from the rear distribution box, and now we can spend time having fun in the back. Okay, so we've got our amp clamp up there running, hooked up. So now we know that there is a high draw on one of these circuits, one of the wires from one of these connectors in the back, which then also go through one of these fuses. There's a couple ways. Well, a pinpoint way, well, sort of pinpoint way, is to find out which fuse it is. Now, on this vehicle, and nowadays you can't be pulling fuses and watching for a amperage drop, because if you pull the wrong one and put it back in, you can wake something up, or even wake something up by pulling something out fuse wise. So we're gonna measure the voltage drop across each fuse to try to find which one's got a big drop on it. Before that though, just because I have the ability to, with the fuse panel like this, and you can't always do this, but I'm actually going to take the amp clamp, again for guidance, and wrap them around sets of wires from each connector to try to find one that is a set, find the connector that has the draw on it, or some sort of draw on it, and I'll show you what I mean. So I'll unhook it, go back down to 0 on the red, and if I can try to put you down, so you take the jaws and then just find any connector. Like I said, you're taking a bunch of wires. Right now you're just trying to find a set that is going to have activity on it. You want to get the jaws to close. And it's got some, nothing too crazy. But we're looking for something to jump out at you on that screen. Here's the next set that I can get around. And still nothing crazy. This one should be easy, just 2 wires. Again, nothing crazy. If I can get around this small set up here. Okay, that's the next set. Nothing. So eventually you should find, obviously, because the feed coming in has the draw. So next set. And look, boom. Okay, and that looks 380. Sorry. So that is about just about the full amount. That's try to get it in the middle, get an average. But okay, so nonetheless, we've found our connector, which is, let me see. Okay, let me. That guy right there. Now, let's see. I mean, just for fun. Like I said, we still got to go to the front side and try to find the fuse. That's not it. Let me see. Oh, these jaws make it so hard. That's not it. And you got to remember which ones you did. That's not it. Okay, so just before I dropped you guys, the next wire I checked was the one. So that. So there I am. Okay, so a couple things I can do. I can try to get on service information, pull up the information on the junction block here, find out that connector, find out that pin, and then kind of go from there. Or we can try on the front side with the fuses. Either way, it doesn't matter. Let me poke some fuses, see if I could find one, and then maybe that'll be quicker. If not, I'll just get on service information. Okay, so to not bore you and checking all of them, I end up finding which one it was. Now with this, get your meter, set it on millivolts, and take the 2 ends and just go across each fuse until you see a high reading, And again, let me try to see if I can show you. And all you do is go across each pin and then look at your meter. And if there's nothing there, it'll go 0.0. If there's something there, it will show something. So let me if I can trying to get set up. I'll just have you on the meter, and then I'll show you. That glare is so crappy. There's one that has nothing on it. It stays at 0. And there's another one with pretty much nothing on it, but here 15.8. It's a huge number. That's what you're looking for. And the one that gave me that is this guy here, this 15 amp mini fuse. Okay, so the fuse in question that we want to find out is in this middle section of many fuses that are set up vertical. Now here's this relay, bottom right, if we're looking at it from the front, and then it's the second one in on the bottom row, that blue one. So if we look at this setup, here's the relay, here's the mini fuses vertically up. That's bottom row, second one in. If that's 129 and that's 133, then it's going to be fuse 130. Okay, so we are a wiring diagram for fuse 130. It's right there. It's a 15 amp fuse in the rear distribution box, and it's that connector is one we were on, X11011. And if you notice, that's red and yellow, which is the color that we did have. Now this is equipment dependent as far as what we're seeing. It's all dependent upon engine. So here's a N57, S63, N63 hybrid, and N63 S63. But what they are all leading to, what's described to say auxiliary water pump 2, same thing, and coolant pump for intercooler. This vehicle, if it is well, I was going to say, if it is a M, it'll be the S63. If it's regular, it'll be the N63. But I was looking, and this is an S63 also, so if it's an M with an S63, it can be one of these two, this one or this one. If not, then just N63, it'll be this guy. So what I am going to do, well, basically we pretty much narrowed it down. We know most likely what it's going to be. It's going to be an auxiliary electric coolant pump, either for the intercooler system or a mini auxiliary water pump for the regular coolant system. I'll punch up locations of this one and this one, and then go to the pump itself and see if I can feel it running or feel it warm, or unplug it. So you can see we're still got a decent draw. Okay, so the auxiliary coolant pump, if it has one, is going to be located front left bumper area, and that's that M37B there. And then the coolant pump, the one for the intercooler, it is M60353. And do component location. And it is showing it to be, looks like that's right side radiator hose, lower radiator hose, and looks like it's right under that. So now we'll go look to see if we've got both of them or just one, and unplug one or the other, or feel them, or kind of go from there. It's hard for you to tell, but now that I know what I'm looking for, I can hear. I don't know if you can hear like a buzzing noise, but definitely one of the pumps is running. I don't hear anything in this bumper area, and I'm hearing it more in this area. So that guy is buried. I don't even think I can get you guys to see without pointing at it somehow. What I'm going to do is get a long screwdriver or something and see if I can hear it. I know it's super hard to tell and you can't even see it, but I've got this screwdriver and it's laying on the pump down there. And you'll just have to trust me or take my word for it. When I touch it, it's buzzing, so I'm gonna say that's your cause right there. The water pump staying running. One last thing I might do is check the control of it, make sure that there's nothing funky going on there, but other than that, I think that's a good place to stop, at least for tonight, and make a good determination of where that high draw is coming from, which it all makes sense. The pump's just continuously running and still running, and that's going down just because it's wearing the battery down. So just odd about that door handle the other day. Let me just, yeah, it's still cold, so hopefully there's not more than one problem as far as the draw, but the coolant pump is definitely the cause of the draw on this guy. So like again, I'm gonna stop there for tonight, and then and that's all. It's been a few hours. Let's see. It is 10:40, coming on 11. Started about 8. So these this said heads up, they're just not fun to do. This one didn't get as crazy, but definitely something kind of unexpected. Wasn't really expecting to see electric coolant pump be the cause of it, but we definitely were able to isolate it to this junction block here, which makes it a whole lot easier trying to narrow down when you've got so many circuits here and in the front. So but you got to be patient, you got to take your time, you got to be thorough, you got to look at everything and then start breaking it down with service information to try to narrow it as best as you can, and then just follow these steps and try to do it this way or close to this way. Then you won't have comebacks with batteries still dying. So hope you found this one interesting, and then if I get anything further from this, then I'll bring you guys along. If not, then I might just end this one here, and that's it.